architecture. Thanks very much.
Cheers. So let's see, do I have to push a button here?
Sorry.
2, is it?
1, 2. 2 seconds.
Yep. So as you can see, we're going to talk today about basically our experience at a local hackathon. So the AINI group set up a hackathon where the theme was to kind of build a solution integrating machine learning, data science and things like that for the good of society. So Daryl and I thought that it would be a good idea to kind of run through what it was that we built, because we thought that the patterns that we use, the architecture that we use, kind of really allowed us to deliver something quite impressive in terms of just the complexity and the scale of what it was that we built. And so this is just a chronicle of that process. So just an introduction, my name's Kevin, this is Daryl. We both work at State Street Bank and Trust, which is kind of a new company to Belfast, probably about 14 months now. So I'm a data scientist there, and Daryl's an analytics engineer. In terms of the actual what we built then, so how did it all come about? As I said, we had the AINI group basically put out a kind of call for attendees to this hackathon, right? So Daryl and a few of the other folks at State Street had kind of decided early on that they were going to go. Eventually they kind of talked me into doing it as well. I had never been to any kind of like hackathons or meetups or anything like that, as Dr. Bolster there will attest. So basically I put the thinking cap on and said, right, you know, what would the idea be? So we kind of went back and forward on the kind of solution that we might want to build. So in terms of just the introduction to the team, in total there were 5 of us. So 4 of us went, and then we met Jusho on the morning of the hackathon. Jusho is a PhD student at UUJ, and she attended just being really interested in machine learning, not having had any experience in that area at all, no experience in programming or anything like that. So we invited her to kind of join the team and see what it was all about. And David here on the far right, he basically provided kind of ongoing tutorials in Python and things like that. So I think Jusho got a lot out of the hackathon, things like that. So Connor, who is beside David, he had a great time, but we're still working really hard to kind of wean him off his addiction to Monster energy drinks. He just kind of went fiend mode, you know. So what we came up with then, we basically sat down. One of the things that has been bugging me for quite a while is just like social media in general, right? So I know it's great, a lot of people get a lot out of it, but there are kind of increasingly reports of issues around social media. So we've all heard of kind of the gamification of democracy, which is one of the big issues. Then we've got online harassment and things like that, and there's kind of emerging research that's showing that young people are adversely affected by their exposure to continuous kind of like negativity online and things like that. You've got this kind of like attention sucking problem where you're kind of on social media and not doing things that are maybe more constructive to your future and things like that. So we were interested in seeing if we could maybe ameliorate this, right? So obviously we're not trying to get rid of social media or anything like that, but maybe kind of make the use of that a more sustainable thing in people's lives, right? So we came up with this idea of basically cutting the cord from the platforms, right? The platforms are there to kind of like process all of the data and like serve up content to us. But we decided that we would kind of sit in the middle of that and create a client that would be multi-platform, that would basically collect, it would kind of intercept a lot of the behavioral analytics that these platforms are collecting, which basically allows them to kind of do such a good job of engaging users, selling ads and things like that, right? So basically limiting the amount of data that these platforms can actually collect from users. Additionally then, we also wanted to give users much more control over the content that they were exposed to, right? So the likes of Twitter and Facebook, they can only possibly apply these global policies, right? They might implement some kind of like personalized refinement in terms of filtering things that you do and don't like. But I'm sure we're all aware, like you're really not creating a massive training data set that's specific to you, that really customizes what it is that you see. These things are really being applied at a global level. And for that reason then, these platforms are in a kind of catch-22 situation where they know that they have to address the issues of online harassment and things like that. But then they also run into the problem of creating inauthentic experiences for users where they're kind of sanitizing the kind of content that people are exposed to too much, and then they lose users and all these kind of interactions. So next step then, so we knew what the idea was. The next step was to basically sit down, figure out how we were going to put this thing together, right? So we kind of listed a few requirements and things like constraints and things around what it was we were going to be doing. So we estimated we probably had at most 10 hours of development time. So the hackathon ran from Saturday morning through to kind of Sunday lunchtime, right? So Sunday lunchtime, most people just spent kind of refining their pitch to the judges. So it was really all day Saturday was the development time. So we decided we would stick to what we were familiar with. We wanted to at least kind of hat tip to scalability, because with social media platforms you need scale because there's so much data coming through these things. We also wanted a flexible data model where we didn't really have to worry about a kind of sensitive database that couldn't be changed or anything like that. So those were some of the main considerations that we had, which basically led us towards microservices architecture where we could just decouple things, right? So this kind of fed into our ability to parallelize the kind of development throughput. So Daryl could be working on one thing while I'm working on a concurrent thing, and we're not kind of tripping over each other. Additionally then, it kind of serves itself well to the data model that we used. We had flexibility in the kind of language that we used. So just because we kind of did the initial ingestion part of our architecture in Java, that didn't then mean that we had to do everything in Java, right? We could pick and choose the best language for the specific task we were trying to solve for. We used event sourcing as our kind of data model or data pattern. This data model, I'll just kind of walk through the diagram here. I don't know if it's very clear. Could we maybe dip the lights, or is that clear enough? Can people see it? Yeah, so event sourcing is basically a way of kind of persistent events that are associated with state changes of a record, right? So let's say you have a bank account. Well, if you have a transfer of money into that bank account, you hold the event that represents the transfer of money into the bank account, but you don't hold the state of the bank account, so you don't hold the kind of balance at that point in time. So the event stream is basically persisted, and then you have these things called projections, which then create the state from those events. So you kind of play the events through a projection, and you get the state of whatever the entity is, be it a bank account, a customer, a shipping order, or something like that. So we basically use that. So our domain object, or the kind of record of interest, was a piece of content. So let's say a tweet, and then what we were doing is we were collecting events that associated state changes on that piece of content. So that should become a bit more clear then with this kind of architectural diagram that we ended up with. So if we go from left to right on this diagram, the first service kind of at the bottom here, let's see, is this a laser? Nope. So yeah, over on the far right for you, we have this ingestion service. So this is basically like a Python service which will call out to the API of the platform and pull in all of the content for a given user's feed. Then that content will be produced message by message onto Apache Kafka, onto a single topic there. And then on the top here, we have this kind of set of three services. These are our content curation services, right? So they basically tag that piece of content. So they'll pick up the raw tweet, let's say, and the first one there is like a profanity checker, so it'll kind of detect whether there's profanity in that piece of content. The next one is then it'll assign a sentiment score to that piece of content, and then the third one is a kind of personal preference classifier where the user, in the UI, the user is actually able to create a training data set, which would then feed into a model training service to then customize that user's preference for what it is that they like to see in their kind of feed. The kind of box here between Kafka and the UI is basically where the state is projected, depending on the view that we were interested in. And then we have this wee API on the bottom, which allows the kind of interaction back from the UI into the data system again. And again, all of that is on a single topic in Kafka, where each of the atomic events are produced with the same key, so that this state generator can kind of aggregate all of those separate events related to a tweet and create a kind of cohesive state. So you'll get the tweet, and then you'll get the profanity tag, the sentiment tag, and the personal preference tag. And then the UI can basically have rules set by the user as to how that piece of content should be rendered to them. So in terms of the planning and stuff like that, we used a tool called Trello, basically just a free tier thing where we were able to kind of create a load of tickets. So we did this beforehand. We kind of scoped out all of the work and then assigned the tasks to the people based on their kind of interest or specialization and things like that. So those were some of the things that really facilitated the throughput. Daryl's going to talk to you a bit more about the details of how we kind of really maximized our throughput.
Well, yeah, so I'll just jump back. I just want to kind of give you a walkthrough of kind of the tools that we use to kind of aid in this rapid development cycle. So as you've seen, we defined our architecture on the day, and we sat down as a team and kind of give a high-level description of what we wanted each of those microservices to do, and then obviously we decided what language we're going to develop them in. So we kind of picked our languages, and then we flowed through. You'll see in the architecture now, I want to call out quite a lot of blue referencing Python. That was just a team choice. But again, as Kevin had pointed out, we did follow a microservice architecture, and these could have been any other language as long as it interfaced with Kafka in the sense of Python. So yeah, we jumped through the project scaffolding. So this too, we used cookie cutter, command line utility, specifically focusing on the Python applications because we had guts of 5 or 6. So through the use of cookie cutter, more or less a command line utility written in Python that lets you generate new projects based off templates. So for the hackathon, we use a template that I've used for personal projects. And I kind of just want to give you a quick demo of more or less exactly what we've done on the day, and kind of give you a feel of how quick it was for us to pretty much decide upon this microservice, give it a name, and then get it straight into GitHub and maybe allocate it to a team member to start development. So I'm in this project in Visual Studio. We have a folder here called Python Cookie Cutter Template, just a basic template on the command line, specifying cookie cutter, passing in the folder, which is the template, prompted with a new name, give it the default version, and straight off the bat we've got a folder which is ready to go. So jumping back to the slides, what we have here is a project structure straight out of the box, a hello world running app, we've linting, testing, scanning, good practices, all rolled in with Git hooks and a build process, which is going to be the output as a Docker container. The cool thing about the project scaffolding is that you can really tailor these to a specific team or a specific use case, and it can really speed up the development process for those specific use cases. So we're aware that project scaffolding isn't a new tool or a concept, but in a sense some languages and some frameworks have taken this concept on and integrated it within their tool set. So I'll call out Angular in this instance. We used Angular for our front-end UI, and Angular CLI is pretty quick. The exact same concept as cookie cutter, built in, spin up a new app in seconds, and also you have integration for adding component services. And then also just like to point out, seen this during the week, that GitHub are now supporting templates out of the box. Thought that was pretty cool and something to maybe make use of in the future. So yeah, once we had kind of used our cookie cutter implementation, we'd used Angular CLI, we had all our code sitting on GitHub ready to go. We'd allocated different developers for different services. And and they could just get going. And the last level of actually developing the application logic, we kind of done these kind of development patterns, which are more or less just sample code, basic functionality of how to maybe connect to Kafka or read from Kafka. And it's a good concept to maybe keep record or create your own in-house for your own development team based on your particular language of choice. We found in the day this worked pretty well, where we had a lot of consistency across different microservices reading from and pushing to Kafka. So it became a copy and paste exercise from the development patterns, and then enabled our developers or the team to just solely focus on the data model of what data was being pushed to and read from Kafka. So yeah, we're just going to go for a quick demo, and we just want to point out we haven't altered the code. It's exactly as it was on the day of the hackathon, so see how it goes.
Yeah, and I had nothing to do with the choice of the name as well, by the way. Yeah, so in terms of a demo then, I'll kind of show you, we've already pushed a bit of data into the UI here.
Full screen. I'll go back one.
Oh. Yeah, so this is the UI. It's beautiful, and you can see that they kind of, and again, one of the guys set up a kind of Twitter account and like followed a few random people. So I apologize if anything shows up here that's kind of offensive to anyone. We have no control over what's going on here, as no one does really on social media. But you can see the kind of mechanism that we took was kind of just to blur content out, right? So based on the user's preferences. So you've got this kind of 3-tab setup. You've got the feed, which if you imagine if you had this on a mobile app, it would be kind of prettified and you'd be scrolling through and you could render this to look like an authentic Twitter experience or an authentic Facebook experience or something like that. And the user would be able to kind of interact with each piece of content like this, so they would be able to go in. We didn't build that part either in the back end or on the front end here, where the user could go in and reply to a piece of content or like a piece of content and things like that, right? But what we've got here is just kind of like a curated stream of the content coming out of the social media platform. But then the extra stuff then is the user's control over that content, right? So this is where the user would basically train their personal preference model, right? So we opted for just a binary classification solution where the user could say, yes, show me more of this, or no, don't show me this stuff. And what would happen then is when a user clicked on one of these buttons associated with a piece of content, well, an event would be pushed into Kafka from the UI, so by way of an API. It would be pushed into Kafka with the same key as the piece of content associated with it, but it would just have a label on it that would say like maybe 1 or 0 or something like that, to say I like seeing this or I don't like seeing this. And that information then would be kind of aggregated in the aggregation service. If we go back to the architecture diagram, so this red one, right? So it's where all of the kind of state is being created. And there's an endpoint there that is basically where all of the users' defined training data set would be held. So that the Python service just above the red service would intermittently, you could set this on a cron, or you could also trigger it by the user, or you could trigger it when the training set is significantly different from the cached version on that service. But it would intermittently call out to grab in the latest training data set, retrain the binary classification model, and then expose that model on an API endpoint for this, then the adjacent Python service to basically call to get a classification of a piece of content. So that gave the user kind of real-time customizable machine learning, right? So they could curate a piece of content. They could say, right, I don't want to see this, or I'm seeing too much kind of like Brexit propaganda or something. So they just go through, put a bit of effort in to kind of start labeling a training data set, and they can see the real-time effects that training data set has on their exposure to the content that they don't want to see, right? So that's the kind of interesting kind of machine learning part. The other part then is like they could have other features. Again, the UI is beautiful, but you can see that if, for example, you've had a bad day at work and you only want to kind of see positive stuff on your in your feed, you can change your kind of sentiment threshold or something like that, and you can go in and save that. And then the idea would be that everyone's being mean on Twitter. You would see that your content would basically change appropriately, right? And you could do things like say, right, I don't want to see any profanity today, so you could do that as well, and you could save that, and then your feed would be kind of curated. Now, one of the really cool things about the way we set this up is that the tagging services are plug and play, right? So whatever you imagine you could do, you could have kind of a multi-class classification model there. You could kind of start to bucketize content in different ways so that you could then run through tabs of things that are specific to this topic or that topic. That could all just be plugged in without changing any of the fundamental design of the application, right? So yeah, that's basically the demo. I'll show you just quickly some data running through. So this is our ingestion. The one on the far right for you is our left for you is our ingestion service. So if I run that, you'll see a bunch of content coming through from Twitter. You can see all of the other services are kicking off here, all the tagging's happening, because those are all kind of like concurrently doing things. Then you can kill that, and if we go back to the UI, we should have seen updates to that, right? So the new content's come through. All of that actually works in reality. Like we're not kind of faking much of this. Yeah, so that's the demo part. So if we go back then, just to kind of finish off the slides. Where are they? Basically, the take home then is don't be afraid of kind of these words that you may or may not have heard, microservices, event sourcing, all of that kind of stuff. Like really, the entry level is quite low. You just have to get stuck in, build something, kind of Dockerize it, or containerize it in some way, and you can, like the way we've kind of spun up that demo is manually kind of like make, run, whatever. But you could implement this in a kind of one-touch deployment approach where you could swap out Kafka for Kinesis, and you could use CloudFormation to just basically deploy that full stack as a single command. Similarly, with something like Kubernetes or something like that, you could use Flux or Helm or something to, again, just do a one-touch deployment with CI/CD and all baked in. So yeah, if anyone has any questions, we're happy to take some now, or you can catch us on email or a GitHub issue or something like that. We're not on social media. Hi.
Like a lot of it looks like it'd be a really nice fit for kind of serverless platforms. Have you considered?
For what? Sorry.
Serverless.
Serverless, yeah. So we kind of, a lot of the work we do is based in Kubernetes, and there's like kind of OpenShift and stuff there, and then there's Kubeless and things like that. But so I was playing around with Kubeless at one point for a lot of the kind of tagging services, but for some reason the Kafka triggers were broken in Kubeless, so it just wasn't viable. But yeah, it serves perfectly for that kind of approach.
What Python libraries did you use to train your sentiment analysis? Was it like NLTK and things like that?
Yeah, well, sorry. The sentiment analysis one was actually just a third-party kind of sentiment thing. So to save time, the profanity one and the sentiment one, we just hit third-party APIs. The only one where we actually trained the model ourselves was the binary classifiers of the personal preference thing, and that was just time constraints, right?
Oh, cool.
But yeah, we would have used NLTK. Andrew?
What finally convinced you to get away from R?
Nothing. I'm still dedicated to it. But if you want to get anything kind of done with other developers, you have to use Python. Yep.
What did you use for the binary classifier?
So we just used a logistic regression. We spent a lot more time kind of, and again, this is a kind of political point in the data science sphere, but we spent much more time on the feature engineering side of things than we did on the kind of model choice comparison side of things. But we could have kind of went with anything from like an SVN or something like that. Yeah.
So when you say you spent time in the feature engineering, what does that entail?
So tokenization of the content, right? So n-grams, whether we wanted to kind of use a bespoke tokenization approach and things like that. So like we had a few troubles there where the difficulty is like when you have a fresh classification problem, you need a training set, right? So if a user just onboards to your platform, there's no training set there to do classification with. So basically that classifier is dead until the user starts to put data into the training set. But again, they could put like 10 messages in there, and that's not going to be sufficient to get accurate classification. So there's all of those kind of problems where we were much more interested in the thresholds around that problem than we were, because that's more fundamental to actually getting any classification versus really good classification.
So did you do some pre-training then on the model? Or?
Yeah, so we used a positive negative approach where we just assumed that people wouldn't want to see negative stuff. So we used basically a corpus of positive and negative reviews to kind of seed the model. I guess that's, yeah. Thanks very much.
Cheers.
It's not till 10:30. 10:30? Yeah. So we've about 10 minutes.
I'm going to be in the lab. I'll be back.
Okay, great.
That's right, I was looking over them, but you couldn't see them.